In this tutorial, we'll be doing a Niagara system that has bubbles that float up, and once it reaches the surface, it pops and does these really nice colorful rings. So I was trying to figure out how to set the surface height so that this VFX will look good on in any water volumes. So in this tutorial, we'll first be going over using a Niagara user parameter. So in this case, it just uses the upper Z, which is the location of this water plane. And then we'll go over how to set that up in a Niagara component on a blueprint. So in this case, it scales really well with the height of the cylinder that it occupies. And then the last is something is definitely new to me, is we're going to use an actor component interface, which is basically a way of Niagara of getting an actor and getting any information from it. So in this case, I just chose the source actor to be the plane, so that one here. And then in a Scratchpad in the Niagara effect, we get the Z location of this. And what's at the heart of this VFX is using this collision module and the analytical planes. It's the cheaper option and it doesn't actually do collisions and allows you to set up a plane to describe where your collision is. Let's go ahead and create the bubbles. So right click in your content folder. In my case, I just placed it in a VFX folder. So right click and then Niagara system. And let's make a system from selected emitters. Next. So we're going to use the fountain for our bubbles. So click on it and then click the plus to add it. And then something with meshes. So upward mesh bursts, it's not exactly what we need, but at least it's a mesh. And let's click finish the wizard. Okay, and I'll call this one Niagara system or NS underscore and then bubbles. Okay, and then let's go ahead and open it. So what I like to do when I make Niagara systems is I like to have an instance of the world just to see what it looks like. So I'm just going to drag it in. So you see the mesh burst happened once. Okay, so we'll just be focusing on the bubbles for now. So I'm just going to go ahead and first disable the gravity. So we don't need any gravity. So you'll see if I disable it, it just goes up. So I'm just completely going to delete it. Okay, so they're going a little bit too fast. So I'm going to tweak the numbers for the velocity and I'm going to move my camera. There you go. Let's change the velocity to be way smaller. So something like this. Okay, that looks more like bubbles. Pretty awesome. And we need way less bubbles. So I'm going to go to the spawn rate and change it to maybe 10. Or let's bump it up a little bit. 20. Yeah, 20 looks pretty good. Okay. And then I'm going to change it to spheres. You could completely keep it in sprites. But I'm going to go ahead and add to my render. So under the fountain emitter, the plus for render, and then it is a mesh renderer. And I'm going to delete the sprite renderer. Good day. And then for the mesh renderer, I'm going to use a sphere. And if you don't see it, it might just be in your engine content. So click the gear and then click on show engine content. So I have this, this whole project is just a empty Unreal project and it doesn't even have starter content. Okay, so I'm going to go ahead and choose the sphere. Okay, so I'm just going to use the basic shapes sphere. So they're very huge. And then for the material, let's just override this material. And let's choose something blue. Okay, so I found one material instance ball 01. That looks pretty good. And then we just need to change our initial particle size. Okay, so we have our sprite attributes, which don't really matter because now it's a mesh. And let's just set it to random uniform, so we have differences in scale. And I'll do from 0.2 to maybe 0.5. So we gotta go even smaller. Okay, so that number looks pretty good. So maybe some of them are a little bit too small. So 0.08 to 0.1 looks pretty nice. Okay, so we have bubbles. Okay, I'll place it a little bit to the left so you can see better. Okay, nice. So we have our bubbles. Okay, so now what we want to do is actually set up the collision for when the bubbles will die. And another thing we might want to do is to make their lifetime longer. Uh, Depends on how low in the water the bubbles will be. So I'm just going to change in the initialize particle. I think it's a lifetime. Okay, there you go. So let's say a lifetime max of 5 seconds. Okay, so now they go way higher. Okay. So I'm just going to make this a little bigger. And the next part is we're going to create our plane. So that will be in the particle update. Let's search for collision. So this logic happens on every time the particle updates. Okay. So this one seems very heavy. So we're going to actually use the analytical planes. And you don't see anything happening yet because we haven't set up what our planes are. So it's interesting because there are two different planes. So let's say you want all the particles to die once they reach that here. But if you have something going up and down, you also want to stop it at the bottom. Then you could have that sort of collision. In our case, we're just going to use the upper collision. Okay, so you can see that the second one is really, really low. So probably further than your kill Z. But this one, if we change it to, let's say 100, so 1 meter, you can see that some particles don't spawn in here. But they do spawn on top of it. So we have to change our collision normal to be -1. Okay. And then you see, okay, they hit the collision and then they bounce back. So I'm just going to change it to 300 so we can see better. Or that might be a little too far. I'll change it to 200. 200 must be, yeah, pretty good. So in our case, we don't actually need any bounds. So that is restitution, so 0. And then you see they stop and then they go a little bit. So if you want that behavior, then that's all nice and dandy. So just to illustrate what these planes look like, I'm just going to put this one a bit higher. So our plane is right here. So that's at 200. And then if we duplicate this and make it go downward, so I'm just going to duplicate this. I think I can just Control C, Control V. Okay, so this one I will add the velocity downwards. So velocity speed, I'll just do this, I think. Okay. All right, so now we have two different fountains. And so for fountain 2, let's add that the other collision plane is at 100. Okay, so you can see that that one has that plane here, and so there's two planes you can play with, and you can make them face down, up. There's a lot of options of what to do with these two planes. And also they don't actually need to point up or down. It can also be sideways collisions. Let's say you have like a burst of leaves coming in onto a wall, and then the leaves hit the wall, and then they could bounce, they could scoot away like this, and it could be horizontal. It doesn't have to be vertical. Okay, so I'm just going to go ahead and delete that second fountain, and I'm going to put this a bit lower. All right. Okay, so the next step we're going to do is that whenever a particle hits that collision, that it will die, and then it will spawn surface rings. Okay, so to kill the particles whenever they collide, what we can do is you can press the plus on the particle update, and then search for kill particles. Okay, so now we have a bool. So essentially, anytime this is true, it will kill the particle. So we can bind it to collided. So to do that, you press the down arrow and then search for collided. So has collided. Okay, so when it has collided, it dies. So that's great. Now we want to link the mesh burst with whenever a particle dies, so that it spawns in the location that the particle died in. So to do that, we can add a particle update collision event. So this will generate a collision event that this emitter can listen to. And then it failed to compile because it requires persistent IDs. So to fix that, you can go in the fountain's properties, and then click requires persistent IDs. Toggle that on. Okay. And it does mention small memory and performance cost. So just as a note. Okay. So whenever we generate a collision event, we want to listen to it here. So we can actually add a stage into our particle. So plus stage, and then an event handler. So what's great about this is that this emitter can listen to an event from Fountain. So you can click on the plus, and then let's search for collision or receive collision event. Great. So this will listen to that collision event. And then if you click on your event handler properties, you can choose also collision event. Okay, so that took a little while for some reason. And the execution mode, so does it happen on every particle? In our case, yes. And then we want to spawn one, so it only showed up once. So let's go ahead and change the execution mode to spawn particles. So the problem with this is that it's only spawned once because the emitter has the spawn burst instantaneous. So let's just delete that. And then for the emitter state, it essentially managed its own life cycle and it just looped once. So we need to change that to be the system. Okay, and then I'll compile and save. Okay, another point I needed to change was in your event handler properties to turn this off. And then, okay, so we have a few things we need to disable. So we don't need drag, we don't need gravity force, we don't need to update the orientation, and we don't need to add any velocity. And the initial mesh orientation, we don't actually want it to be random. we just want it to face upward. So we're just going to choose orient to vector and then up. Okay, that looks good. And also we don't want it to be arrows. So for that, you can click here or click on the meshes themselves. We're going to remove one of them. Okay, and then we can choose the circle. So we might not be able to see it. Okay, so if you show plugin content, then you'll be able to see it. So I'm just using anything from the engine or plugins. So I like to use the circle 3 mm. Okay, so we almost have it. It's just not facing the right way at all. So to fix that, let's go to our initialize particle or initial mesh orientation. And if I say system, I wonder. Nice. So if I mention system, then it's facing the right way. And okay, I'm just going to go ahead and delete those modules we don't need. And I'm going to change the initial size to be more 0.2, maybe 0.4. Okay, that looks pretty good. Okay, so there's a lot of bubbles. I can always just change the spawn rate to be less. Okay, that looks much nicer. And also it'd be nice if the lifetime of the upward mesh burst or the rings is shorter. So that would look nicer. I'm going to go and initialize particle. And then in the lifetime, I'm going to change it to maximum 0.5, minimum 0.3 maybe. Okay, nice. That looks better. Okay, so we have some bubbles. We have some surface rings. The next part of this video is that we want to have a user parameters that we can expose to our system, so we can set it in Blueprint or in the level instance. Okay, so setting the collision plane in the Niagara system won't work for every single system we'll place in the world. So now we actually need to set a variable that sets what the z height is. So let's go ahead and create that variable. So we can create a variable that's exposed to users this way. And so you just click the plus beside user exposed. And I'll make a new one. So this one will just be a float. Okay, and then I'll call this water z. And I will just initialize it. If you want to initialize it, you have to click on the user parameter tab, and then you can initialize it to, I'll change mine to 200 to match what this one is. Okay, and then I'll save. And then now you should be able to see it here. And if we change it, it doesn't modify anything because we haven't hooked it in yet. Let's go ahead and do that. So in your collision, let's scroll down, and then in our collision plane position 1, which is the water surface that we're choosing, you can click this just to break that vector. I'm used to break a vector, but if I search for break vector, it shows me make vector. So that is exactly what I want. Okay, and then in the Z, we can actually choose our user param that we created. So water Z. Save, then compile. Okay, great. Okay, so now it should have updated. And we see that it's so high that the lifetime doesn't even exceed the height of this water. So maybe we'll have to bump up the life. I'll change it to maybe 300. Okay, so at 300 it shows up. So you see that there's a lot of finagling you have to do when making Niagara systems. So I'll go ahead and change the life of the system. So if I click on the initialize particle, and then in my lifetime, I'll set it to 10 seconds. Okay, so now when I set it to 500, it should be good. Okay, so at 500 it also worked. Okay, and if I change it to 400, that should also be good. So it might just be that the drag is way too strong. So we can see them really slow down by the time it arrives to the surface. So I'm going to go ahead and also change that. So the drag should be way smaller or even non-existent. So I'll put +1, should be good. Okay, so that looks better. Okay, so the next part is instead of setting this number all the time, we'll just set up a way that we can use a reference to a water plane. So this plane is essentially just a plane that I placed in the map. So over here, and then shapes plane. And then I just set the material MI pool, which is in a plugin called Datasmith. We're going to set that up so that wherever we place this plane, or our VFX will update to stop at that plane. Okay, so for this logic, we will actually need to create a user parameter for an actor reference. So to do that, go to your parameter tab, and then in user exposed, just press the plus and then search for actor, and then you'll see there's an actor component interface. So it's great because it gives you access to an actor and its component information. So let's click on that and then call this one water plane actor. Okay. And you could also have some logic that uses, let's say, a water volume, and then it could calculate where the surface is. But for now, let's just use a water plane. It's simpler. Yeah, so this will show up in your Niagara system over here. So I could technically already choose our plane 4 if I click on the eyedrop. Okay. It doesn't do anything yet. So what we need to do is we need to get that C actor position from the actor and put it in a parameter that can then be used in our collision plane. Okay, so what we want to do is whenever the emitter spawns, press plus, and I'm going to add a new Scratchpad module. And I'll call this one get water Z from water plane. So it's a little bit of a mouthful, but it's very descriptive. And this one will take an actor component. Okay. And then it can get the position, I think. Location. Get transform is what it is. Okay. And so we can get all that information from our actor, which is really neat. So Scratchpads were making me scratch my head a little bit, and I think I understand more, which is why I wanted to share this tutorial. So from a position, or when we output, we want to output to a certain variable. So I noticed that I couldn't access our water Z variable. So what we need to do is we need to create an emitter part attribute. Okay, so this will persist over the emitter. I was thinking maybe I needed to put it in the system to be accessible everywhere else, but I couldn't find a case where I would need to know this in the other emitter I have in my system. So I'm gonna add a variable in our emitter attributes, and this one will just be a float. Okay, and then I'll call this one emitter water Z. Okay, and then now I was able to get it. Okay, so our output, this is what it says. So I needed to have a way to get the Z. So these ones are also really, really unique. It's not similar to materials or anything. I'm guessing it might copy other software that VFX artists are used to. So in this case, we're changing our position into a float, and we need to drag the Z out because we only care about the Z position of this plane. Okay, so that's great. That could work. But then for the Niagara system that don't have their actor component set, we still want to use the value from our water Z. So I'm going to add another connection pin. And this time again, I can't see the water Z. So I just need to make a float. Okay. And here is valid. I was searching for a branch and then it suggested select or if. Okay, so if our actor is valid, we want to use the output from the actor position, Z. And if not, we want to default to the user parameter for the water Z. Okay, and then we plug this into our emitter water Z. So whenever this module runs, we'll update that variable. So I'm going to click on apply to this script and compile. And then in our system overview, we have to make sure that we hook in our variables. Okay, so for our float, I think it can have a name. Can it? Yes. Okay. Let's say user water Z input and apply. Oh, okay. I'm not sure what that warning was about. And then system overview. Okay, and then user water Z input. We're going to use our water Z. So it's interesting how the variables plug into each other. And some variables are just at the particle scope or emitter. At first I made a particle variable and then I couldn't set it in the emitter spawn because it wasn't per particle. So, okay. And then for the actor component interface, we can search the one that we already have. So the water plane actor. So those two variables will make it into the Scratchpad and then basically output which water Z we actually want. So now we actually need to use this variable in our collision module. So let's go back to our system overview and then click on collision. And then instead of using the user defined water Z, we're going to use our water emitter water Z. Okay, so that was a mouthful. And I'm just going to compile and save. Okay, the error was that I was using emitter water Z initial. So that was getting the initial value from a spawn script, which is nothing yet. So just make sure to use the emitter water Z, not initial. Okay, and then compile and save. Okay, and then let's see in the level. So we see that now it stops at that surface, which is nice. And then what happens when the actor is not set? I'm just going to minimize this. So if it's not set, then it defaults to whatever water Z value the user entered. So I'm just gonna put it back here. Okay, so the next part of this tutorial is we're going to create this water cylinder. Okay, so I'm going to go to content, and then I'm going to create a new, this time I'll just make it a cube. So a new, just a straight up a blueprint class, and then actor. I'll call this one water volume. Okay, and then I'm just going to add a cube. So cube, and then I'm just gonna double verify or double check what material I use for this one. So on the cylinder, I used this one here. Okay, which is the MS glass material. So I just navigated to it, and then it's nice whenever it's selected in the content browser, I can just click this to use the, oops, I can just click this to use the selected material. Then compile, save. Okay, and then I'm gonna add a Niagara particle system component. Okay, so, and this one will be the one we just created. So bubbles. Okay. Okay, and then what we can do is we can change it here. But in my case, I actually want to attach to a scene component so that it scales correctly with the cube. Okay, so I'm gonna add a new scene component. Okay, I'm gonna go ahead and add a scene component and then make it a child of cube. Okay, and then I'm just going to make sure that it's at the top. Okay, that looks pretty good. Okay, what we can do is in the construction script, we can either set the water Z directly, or we can set the actor or component parameter. So the first step, we're gonna just set the water Z directly. So in the construction script, I renamed my scene to water surface. So let's grab it. Let's get the world location. And then let's break this up so we get the Z. And so we want to set our user parameter. So it's called float. And then Niagara set Niagara variable float. And then this is just called water Z. I'm just gonna double check that. So if I click that, water Z, okay, that's the right one. Okay, so whenever the construction script happens, we make sure to set it to our surface. So you can see that it is a bit lower. So what happens is that our bubbles, they die before the surface. So we might have to add a little offset or play with the collision settings of when the particle dies. So since the scene also scales with it, it's probably better to fix our Z offset in the Niagara particle itself. So in our bubbles, whenever our collision happens, so it calculates it by the bounds. So what if we choose, there's not that many description. Okay, so the mesh could be it. And then the mesh, let's do that at minimum axis. We're just trying things now. Okay, so we can probably change that back to be flush with the surface. So I'm gonna move the water surface back down. Compile save. Okay, so that surface looks good. And that surface looks pretty good. Nice. I'm gonna change the speed of my camera because it's a little hard to see. Okay, yeah, that looks pretty flush. Same with that one. So it's nice that you see the bubble pop a little bit. The next thing I tried to do is to set the component parameter directly here, but there was no node for set parameter. There's a node for set actor parameter, which could be very useful. I did find a forum answer for this. I will post it in the description. And so if it's something you want to do, then follow that link. And it's pretty good at explaining how they figured it out. So yeah, all in all, this has been a great learning experience for Niagara, and I'm finding it very powerful. And at first, it was a little hard to wrap my head around it, but now I see just how extendable it is, and I think I can get better at making VFX. Thanks for watching, and if you like this video, please hit the like button. See you in the next one.